Now that we've talked about the benefits or the pros of completable futures, let's take a look at the other side of the coin, which are the downsides or the cons of completable futures framework. So as I like to say, everything's not unicorns and rainbows all the time, and there are some things you have to be aware of that may be limitations. And sometimes you can address those through various means, but you at least need to be aware of them. Again, we're going to look at this in the context of the parallel streams framework to compare and contrast the degree of effort required to program with each of these different models. So, bottom line, it is generally easier to program with Java parallel streams to get parallel computation than it is to use completable futures with parallel computation. And on the left-hand side, we see the parallel stream version. And one of the things that makes this nice is because we're using streams in both cases, the overall flow is very similar. So that's sort of a good thing. But the other thing is that it still is easier to reason about code that is synchronous. And if you look at this code, everything here is synchronous. It's not asynchronous, which is nice. So you can think about it. And the reason why we get a speed up is because we're doing all this synchronous computation in a pool of threads, in the common fork join pool. Conversely, on the right-hand side, we have a sequential stream as opposed to a parallel stream. And all the things you see going on here are all running asynchronously. We're downloading images asynchronously. We're applying filters and storing the transformed images asynchronously, and so on and so forth. So there's more complexity lurking under the hood. Now, what's interesting about this is because we do use streams, at the top level, it looks very similar. The difference here really comes to the fore when you were to look at the implementations of these methods. Now, once you've had experience programming with this stuff, it's not that bad, but it is more complicated. So async behaviors are more complicated than the sync behaviors, even though the overall streams framework makes life easier. The thing to note here is that all these calls use two-way synchronous operations, and they quickly discard cached images from consideration in a synchronous way using a filter operation. And what's notable about this is the first thing you do is you take each of the URLs, you go out and you see if they've already been cached. If they have not been cached, you proceed to download them and filter them. If they have been cached, you just ignore them. So once something's ignored, downstream activities have nothing whatsoever to do. In contrast, the behaviors here, which we didn't really go over in detail, but if you watch the other videos from my other classes that have covered this in detail on the image stream gang case study, you'll see that all of these behaviors need to deal with optionals. And that's because when we start out downloading something, because we're using completable futures, we can't filter them. You can't apply a filter on a completable future because it's not got a value yet. You have to wait till it's got a value, and that would defeat the whole purpose of completable futures. So instead, we wrap everything up here into optionals, and then we pass the optionals down through the stream. And the way that these other behaviors are implemented is that they have to explicitly check to see if they've got an empty optional, and in that case, they do nothing. Otherwise, they do whatever they're supposed to do, download, filter, store, and so on. So the behavior here is more complicated, and the code is not quite as intuitive to look at. However, if you're going to go to all that trouble, you might as well get a win. And as we talked about before, there is a win, in fact, by using the completable futures implementation. So things are faster, but it's more complicated. So the trade-off is between sort of performance and productivity. Why is this the way it is? Largely because most people learn computer programming with synchronous abstractions. Most people start out by doing things with Java or Python. The vast majority of stuff that you do is synchronous. And then only later, when you get to courses like this, will you see anything about asynchrony. Also, if you take a web programming course, you may learn a bit about asynchrony as well. But the web programming abstractions for asynchrony are not typically as clear and clean as the Java completable futures ones are. So as a consequence, we just haven't thought as much about the patterns of asynchronous programming, so it's not surprising it looks more complicated. Once you learn them, they're not quite so bad, but it is a learning curve that you have to climb and master at some point. So bottom line, parallel streams are easier to program, but are less efficient and less scalable. My suggestion is, if you're actually doing this for real and not just doing it because it's a class assignment, you would probably want to use sequential streams to get things to work. And then once you got the logic correct, then you could switch from a sequential stream to a parallel stream, usually with very minor changes in the code, minuscule changes. That's a good thing. So now you've got, hopefully, a performance boost with really no extra effort. And you would only go to the trouble of using the completable future stuff if you discovered that you couldn't get the performance you wanted by using parallel streams, which, again, benchmarking helps. I think JMH is the Java Measurement Harness or something like that. You should look it up and see what it stands for. So, as usual, understanding best practices, understanding good principles, understanding design patterns needed to program completable futures helps you to be able to more effectively balance the trade-off between performance and productivity, so that once you master those patterns and best practices, you get the performance and the productivity at the same time, which does occur, but that takes more practice, which of course is why we're doing the assignments. So that's the end of the cons of the Java Completable Futures framework.